Is the screen visible?
Yes, sir.
Okay. So what are the components of this segmental lining? Now, segmental lining, whenever in the tunnel after the installation, whenever we are going for the inspection, we are seeing a ring and there is a continuous number of rings. If it is a 3 kilometer tunnel, you can see around 200 to 250 rings. Now, each ring, they have certain number of pieces. So it can be 5 plus 1, it can be 6 plus 1, it can be 8 plus 1. So 1 is the key and the rest are the other pieces of the segment. So segment means each precast concrete piece of the lining, and whenever they are joined, they are making the complete circle. So if it is a 5 plus 1, that means there are 6 pieces. So each pieces they are joined by bolts. Now the bolts, it can be circumferential bolt, it can be longitudinal bolt. There are also counter key segments. Counter key segments means the key piece, that is the joining of the all the segments. And there is two part of the segment. One is called the leading edge. One is called the trailing edge. Leading edge means that is the edge that is very close to the tibia, and trailing edge means that is the other end of the segment. So leading edge means that is the part where the TBM is putting the thrust. Now the ring length is generally sometimes it becomes 1.2 meter, 1.4 meter, and all these rings when they are joined, they are making the perfect circle, and that is the finished diameter of the tunnel. So it can be 5.5 meter if it is finished dia, it can be 6.5 meter, it can be 10 meter, whatever the dia is. Now this is the key components of the segmental lining. So whenever you are seeing one piece of the segmental lining, you can see there are several parts. One is called the longitudinal bolt, and another one is called the circumferential joint. So one is the longitudinal bolt, means there are two types of bolt as I told you. One is the longitudinal bolt, another is the circumferential bolt. So you can see here there are two type of bolt pockets. So basically bolt pocket means this is the in the mold, this is already there is a groove, and when the segment is casted in the groove, accordingly this opening is formed. So this is depends on the what is the dimension, what is the size of the mold. So before any type of segment casting, you need to check all the mold dimension. So accordingly, if the mold dimension and if the tolerances are fitting within your structural dimensions or not. So first of all, there are longitudinal bolt and another one is the circumferential bolt. Then there is a one called erector cone. Erector cone means this is the part from which the segment is being erected, because you have to lift the segment after the casting. So you have to make the demolding and then you have to put it for the curing also, and then you have to stack the segments. So this is the part where the segment is being lifted. So erector cone is basically the part where the segment will be lifted. Now, sometimes you are putting also alignment dowel. It's optional, but alignment dowel basically fixes that how the when the segments are being placed and when the ring is being formed, how they will follow the curve, because the TBM, whenever it is negotiating any curve, as I told you earlier, it is basically the when it is negotiating the curve, the segment should follow the same path. So we are providing some types of dowels at the circumferential edge, so it can guide the segments to follow the path of the TBM. And another, so this is the mostly the part. So one type of bolt you will see that is put in the circumference, and another part is in the longitudinal. Longitudinal means along the length of the segment. So these are the key components of the segmental lining. One is called the spear bolts. Sometimes you are putting bolts, or sometimes you are putting dowels also. The spear bolt is one type of bolt that is mostly put in the longitudinal. So if you see in the two segment, between the two segments, there are connector bolts. So these two bolts are connecting the segments. So at the joint of the two segments, there is a small groove where we are putting the gaskets. So the gasket is basically the waterproofing membrane. In an NATM tunnel, we are putting a waterproofing membrane before we are doing any final concreting. Here there is an inbuilt uh, waterproofing system that is called the gasket. Gasket is basically a compression membrane. So whenever the segments are connected and whenever they are joined, so due to the compression, the gasket makes the joints between the segments waterproof. And here you can see this is the face of the edge of the segment. Here we are putting some sort of pipe, some sort of this is the first face of the segment. So we are putting plyboard here. So directly, whatever the jack or whatever the ram it is directly not applying the loads to the segment trailing edge, the leading edge. And this is called the guide rod. Guide rod is also one type of system that controls the alignment. So guide rod or the dowels is they are controlling the alignment or controlling the how the segments will go as per the TBM movement or as per the curve. And gaskets, there are three types of gasket. One is called the elastomeric gasket, one is called the hydrophilic gasket, one is called the combination gaskets. Now, depending on your waterproofing system or depending on the area you are working or whatever the water ingress it is being expected or what is your future serviceability or durability, we mostly the client mostly decides in his contract that whether he wants to go to a single system gasket, whether he wants to go with a combination gasket. So it depends on. So if it is an elastomeric gasket, hydrophilic gasket, then both gaskets are joined and sealed. And sometimes it comes with a composite gasket also, where the hydrophilic and the elastomeric gasket both are coming. Now the gaskets are installed after the before the segments are being lowered in the TBM shaft. They are being installed. Nowadays there is also a system that is called cast in situ gasket. The gaskets are coming along with the mold. So when the segments are being casted in the mold, the gaskets are fitted. So you do not need to fit the gaskets after before the lowering of the segment, because sometimes it happens that if the gaskets are not properly sealed or not properly placed, sometimes they get loosened also whenever we are lowering the segment, and you see that the gaskets sometimes it gets displaced also. So this is the three types of bolts. One is called the double, one is called the card bolt, one is called the spear bolt. These bolts are mostly we are putting between the two segments, and there are it depends on that what is your type of the alignment. Accordingly, you have to put the bolts. These bolts are permanent bolts. It can be temporary bolts. In several projects, we are removing the bolts. In several projects, we are keeping the bolts. It is up to the client, whatever it is contract being placed, because these bolts are not carrying any type of structural loads. So this is just for the joining or just for the dictating the according to the alignment of the card, and it is mostly it is the joining of the segments to make it as a complete ring. So you can see one the dowels mostly we are putting wherever it is a very hard rock or hard stratum. So or in the cross passage area also we are putting some nowadays we are putting the dowels. So dowels are basically whenever there is a recess or whenever the area we are going to remove, so dowels will take the load of the balance segment that is being left. So this is all the components of the segmental lining. Okay. Anyone have any doubt or any question here?
Sir, regarding bolt, temporary and permanent.
Mhm.
So, in which case it can be temporary and in which case it can be permanent?
In my experience in all the projects, we never remove the bolts, but in Delhi Metro, some of the initial phases they remove, because what happens after all the segments are joined, they are making the perfect circle. So it's automatically they are connected. So you don't need to the bolts has no further, but it is nothing from the structural point of view that the bolt has to be kept or bolt has to be removed. Because if your alignment is perfect, or if you're whatever, if you're not finding any stepping or leaping or whatever after the legal survey, you do not find any deviation, then it is preferable you can remove the bolts. It is there is no so specific guidelines.
So, in
Because
cross
it's a
passage
temporary,
location, there is
yes.
any function of the bolt during
Yeah, cross
opening of
person
the segment?
location. Yeah, I show you. This is a very interesting thing. I show you. Basically, the bolt is to whenever you are building the segments, that is the holding of the segment, the bolt performs. Because someone has to hold the segment because all the rings are not in place. So that is the purpose of the bolt. Here you can see what we did in previously for the cross passage opening. We used to place frames. So we used to place a temporary frame. The frame can be half frame, the frame can be a full frame, and then the particular either I remove a full segment or either I remove two parts of the segment, half piece of the both segment. Nowadays, it was also done in Chennai Metro also that they did not put any temporary frame. What they did, they put here beep plugs. Beep plugs means this is a type of dowels, and here they have put special type of tension rod and dowels at the cross passage opening. So when you are opening this part, the other segments or the main segments they are not getting disturbed because the beep blocks is basically taking the increase in the load because in this part there will be concentration in the stresses. So other segments we are not. This is the dowels are taking the loads, but here we have put it tension rod and dowels. So we are not putting any frames here. So
But sir,
one part.
in
Hmm,
our current project,
hmm,
that
hmm, hmm.
opening size is more, most probably four ring means four
Oh,
segment to be removed, like a
yes, yes.
1.5 into 4, 6 meter opening. So in that case, it
Ah,
is now preliminary stage, not a detailed design
hmm,
stage. So
hmm.
in this case, so is there any major function shall be by using permanent bolt or some other concept can be applied?
If it is a very generally our cross passage I think is 1.4 by 2.1 meter in all the metro projects in India. So we
Yes,
mostly
but it is
remove I
a
think.
vent shaft. Like a, in this
Hmm,
project, they are remove all the cross passage. So everywhere they are using ventilation shaft. Some
okay.
area, some other activities are there. So minimum opening is 6 meter. That means four
Hmm.
segment, 1.5 meter width.
But better if you put dowel that is better rather than both dowels take more load at the junction at this point. Just show you. This was also done in Pune Metro also because the Pune Metro, the rock is very hard. So we put here dowels because the dowels can take the more torque of the segments or more thrust of the segment. Yes, this is we are putting here. This is the dowels here we are putting. So whenever there is a rock, the torque or the thrust will be very huge. So the dowels can take this amount of the loads. But this concept, whatever I showed you, this was also shown by Gulemark when they are working in the Pune Metro project. They preferred not to go with a frame because they told the frame installation is a very long process. You have to install the frame, then you have to remove the frame. So rather than installing the frame, we can make it adjustment when you're casting the segment. So if it is a 1.4 by 2.1 meter opening, so we generally take one full segment or we generally take half of two segments. So particular for that sacrificial segments, they made a very special segment. They proposed a special segment, and that special segments they proposed to put dowels here or tension rod and dowels here. So whenever this portion is being cut, so this tension rod and dowel will take the load. And other segments they have put beep plugs. So beep plugs means they're basically dowels, and these dowels will take the all the loads that will come at the edge. And this is also being practiced in abroad also because nowadays in the advanced technology, lots of people are not preferring to use the frame. But if your opening size is very huge, then you have to need to adjust in your segment arrangement.
Okay, sir.
Okay. Now we come to the ring tapering. Ring tapering is very important because whenever you're aligned, whatever the alignment, it is not a straight, it is a curve alignment. Sometimes it is a curve, sometimes it is a straight, sometimes it is a left hand side curve, sometimes it is a right hand side curve. So depending on the type of the curves, initially what we did, either we keep a left hand taper or we keep a right hand taper. But nowadays we are doing a universal segment. So it is a both side taper. Now, what will be the amount of the taper? That is a formula you can determine what is the amount of the taper. So you can see that it is a trapezoidal type of the segment. So what is the minimum width of the segment? What is the maximum width of the segment? What is the nominal width of the segment? You can determine. Now, if the taper, it is a left hand side taper, it is a right hand taper, or it is a upward or it is a downward ring. Nowadays, we are going with a universal ring. The universal ring means it is a both side taper. So you don't have any problem to negotiate any type of curves. I will show you. So this is the basically when the segments are being arranged. So this is the plan of the arrangement. So you can see that how the segments are being placed. So basically the segments, if there is a six number of segments, so it is basically marked S1, S2, S3, S4, S5, S6. Now S1 in my case, it is the key segment and other segments are the main segments. So you can see how the segments are being placed and how the bolts are being placed. So the bolts are in both directions. So this way, the segments are being built continuously along the length of the segment. And in the bottom, you can see there are very small holes that is called the dimples. Dimples are basically very small diameter holes. This is mostly we sometimes we keep it the dimples for additional grouting also. There will be grout holes. There will be grout holes for the doing the primary grouting. There will be lifting socket also. But also we sometimes keep the dimples if we need additional grouting. Now, how the number? What will be the number of the dimples? It generally what in the mold it is fixed that the what will be the number of the dimples. But if the as per the project requirement or as per the site requirement or as per the groundwater condition, if I need additional dimples, that need to be specified by the designer. Okay. Dimples are generally 15 to 8, it is 18 mm diameter. It's a very small size hole. If you go to the, when the segments are being installed, you can see there are very, very small holes. There are separate holes for the grout socket and the lifting socket, but apart from the grout socket and the lifting socket, very small diameter holes you can see in the segments. So that is called the dimple. Now, sometimes we see there is a stepping and leaping of the segments. So that is called cruciform joints. Basically, it forms when the segments are not being able to, or the TBM trailing edge is not being able to uh, counter the curve. Because if it is a very steep curve, sometimes the trailing edge of the segment or the tail end of the segment gets stuck. And at that portion, whatever the segments are being built, it comes that all the segments are joined. Because you can see here the segments are not in a line, they are in a offset. So that is why it is being managed, the curve, or you can say the tapering is being managed properly. If the curve is not being managed properly, here the cruciform joint forms where the segments are coming in a common line. You can see all the segments are coming in a common line. So what happens in this part, that the functionality or the serviceability of the waterproofing membrane or the gasket, whatever is being installed, it can get dislodged or it function gets affected. Because if they are joined in a line, then the gasket is also getting dislodged at that part. So what we do if the cruciform joints are, if I found that the cruciform joints are formed for a number of segments, we need to check that if the gasket is being dislodged or the if there is a sometimes we see there is a discharge coming of the grout or the water is coming out of the joints, then we have to make a separate methodology, or you have to make a separate methodology of the repairing of the segments by doing grouting through these joints. So the contractor develops a methodology separately. He submits to the designer to make it as a waterproof. So here you can see there are two figures. So this is the bottom one is there is no cruciform joint. So this is the perfect arrangement, and above is the cruciform joint. So if it is a stepping and leaping, so you need to check that what is the extent of the stepping and leaping, and you have to instruct the contractor to develop a methodology for the repairing of the segment. Now, how we decide the thickness of the segment, how we decide the length of the segment, and how we decide the system of the segment being. Now, there are some recommendations from the standard. There is a AFTS recommendation that is from the French Tunneling Association. There is the International Tunneling Association recommendation. There is a German Tunneling Association recommendation. There are lots of, there is a British Tunnel Society recommendation that how we decide the thickness of the segment, how we decide the length of the segment, how we decide the diameter of the ring also. So the recommendation is that basically whenever we are specifying, it is the inner diameter of the segment. It is not the total diameter. It's only the finished diameter of the ring. So it basically the tunnel there is a ratio of the internal diameter to the lining thickness. So it varies from 18 to 25. If the tunnel internal diameter is up to 5.5 meter, if it is between 4 to 5.5 meter, then it is 15 to 25. And we are generally specifying a ring length of 1.5 when the tunnel diameter is 6 to 7. If the tunnel diameter is more than 9, then we are going for a ring length of 2 meter. Ring length of 2 meter means we are specifying this length. We are specifying this is the length of the segment. So whenever you are seeing this is the arrangement, so this is the thickness of the segment. So if it can be 275 mm, it can be 325 mm, it can be 350 mm, and along the length it can be sometimes it is 1.2 meters, sometimes 1.4 meters, sometimes 2 meters, depending on the diameter of the ring. So what is the diameter of the ring we are specifying. Now what is the thickness of the segment? So it generally we go for a 12-inch segment, that is the 300 millimeter segment, because as per the German Tunneling Association, they recommend that the segment thickness should be minimum 300 millimeter. It is a one pass tunnel lining. One pass tunnel lining means that is there is only one lining. In NATM tunnel, we are going with a two pass lining, because in the NATM tunnel we have the primary lining, that is the shotcrete lining, and then we have the final lining, that is the concrete lining. So all NATM tunnels are called a two pass lining. But in TBM projects, it is a one pass lining because the only single segment you are putting, and that is taking into account of the all the primary as well as the final. Now, what is the ring length that I told you? The ring length can be 1.5 meter if for the tunnel diameter of 6 to 7 meter. If the ring length can be 1.8 meter, if the tunnel diameter is 7 to 9, more than 9 meter, we generally go for a ring length of 2 meter. Now, currently, we have also ring length of 2.2 meter. Another thing is the slenderness ratio of the tunnel segment, that is the ratio between the breadth and the curved length of the segment. So that is the very important, because in several projects we are specifying what is the slenderness ratio of the tunnel segment. So it generally it varies between 8 to 13. Sometimes it is 10 or sometimes it is between 12 to 13. Now, what will be the ring configuration? Ring configuration means what will be the total number of the rings? Because for making the complete circle, there are several pieces. So it can be 5 plus 1 configuration, it can be 7 plus 1 configuration, it can be 9 plus 1 configuration. Nowadays, in very high diameter tunnel, because around 14-meter diameter or 12-meter diameter tunnel, we are making a ring configuration of 9 plus 1. Now, 1 is the key and 9 is the main pieces of the segment. It can be a single key, it can be a double key also, depending on your configuration of the diameter of the tunnel. So generally in all the metro projects we are currently working, it is a 5 plus 1 configuration. So it is total 6 rings. That means the 5 is the main pieces and 1 is the key piece. Okay. Anyone have any question or any doubt here?
Yeah, sir. So that
Mhm.
5 plus 1, why it cannot be 4 plus 1 or 3 plus 1? Any restriction minimum shall be 5 plus 1?
No, it's just a recommendation. It's generally preferable to, because if you make the length of the segment more, no, it's one of the problem is the handling also. Because you have here I show you. Basically, in the segment design, apart from the structural, there is also one thing is the production and the transition stages. So in the production and the transition stages, one most important thing is the handling, storage, and the transportation. So if these moments are very high, in the temporary stage, we'll have a very high moment, and these moments will cause, if the at the edge of the segment you don't put the proper reinforcement or proper arrangement is not there, you can get cracks. So basically, the length of the piece is curved length of the piece is, that is why it is restricted. You don't have additional handling moment. So that is why the number of pieces has been defined by the different design guidelines, or you can take the different country codes as per their experience. It's not that I can make as a 3 plus. You can make it as a 3 plus 2, but what happens for making that 5.5 meter circle, your pieces length will also increase, or your key piece will also increase.
Is there any formula to calculate number of based on diameter rings? Or is
Pardon?
it like by referring the minimum length guidelines we have to calculate?
I cannot understand. It's not clear. You sound.
So am I audible now?
Yes, yes, yes.
So is there any formula to calculate it? Means number of rings, or do we have to
No,
calculate
no,
it
no.
by considering the
No,
minimum length from the guidelines and then calculate the numbers
no,
as per
it's
the
not a
diameter?
formula. It's a recommendation. It's a codal recommendation. We don't have IS codes for this Precast segments, but we generally follow the British codes, or
Okay.
we generally follow the LTA guideline of the Singapore. So all these guidelines, they specify that according to the tunnel diameter range, there is a range. There is not a fix that for this tunnel you have to go with these pieces. It is, so you can see here. So it's a basically they are providing a range according to your diameter.
Okay. Okay.
So
Sure.
up to 4 meter diameter, it's a 5+1 configuration. If it is 8 to 11, it is a 7+1 configuration. And as I told you earlier, that one is the key piece. So key piece, sometimes people are keeping it as a two piece also. In several countries, they are going with a two key piece also. Whenever the tunnel diameter is very high, they go with a 9+1 concept. Now, currently, the Bangalore Road tunnel, that is, I think it is around 14-meter diameter, that is the Adani is doing. So, the segment configuration was around 9+1 because the tunnel diameter is more than 12 meters. So, the key configuration has been decided based on the handling and the demolding or the lifting. These moments, these temporary moments are minimum, because if it is very high, then you will have cracks in the segment, then you will have problems also in the segment. This is not of a structural configuration. It's basically because, as I told you earlier, the segment, whenever you are designing the segment, there are three types of load. I show you one. There are one load is the production load, one is the construction stage, one is the service stage. The production means when you are working in the segment precast factory. So here there will be a demolding, there will be a storage, there will be transportation, there will be hand. Construction means when the segment is being installed by the TBM. So that time the segment will experience the drag forces. Then the segment will get a grouting pressure. Then it will get a secondary grouting pressure. After all these stages, then comes the structural loads. This is not the same as our conventional NATM lining. In NATM lining, we are making a cast-in situ lining. So once the cast-in situ lining is over, the lining will take the loads. But in segment, there are lots of temporary loads before the segment is being placed. So considering this temporary loads, the configuration of the ring or the number of the pieces has been decided by the different country guidelines. We generally don't want to make a new arrangement. Understood?
Okay. Sir. Got it. Thank you.
Now this is the segment gaskets. As I told you earlier, that this is the basically the waterproofing membrane of the segment. In NATM tunnel, we are putting a PVC waterproofing membrane. We are putting a geotextile felt, then we are putting a PVC waterproofing membrane. Nowadays, people are going with a spread waterproofing membrane also, but in and it is being placed in the site before uh, placing the reinforcement. We are putting the PVC membrane in the NATM tunnel, then we are putting the reinforcement, then we are putting the gantry, and then we are casting the segment. So it is installed in the site. Here it is not the same place. Here what we are doing before lowering the segments, we are putting the gaskets, or we are installing, or we are gluing the gaskets in the segment. So as I told you earlier, there is three type of gaskets. One is called the standard gasket EPDM, one is called the hydrophilic gasket, one is called the composite gasket. EPDM is basically propylene diene monomer. This is basically a organic compound, and it's a rubber compound. It's a highly compressible material. Whenever the segments are joined and they are forming a perfect ring, this gasket gets compressed, and once the gasket is getting compressed, it is being a watertight. Now, if it is a cruciform joint, if it is a stepping and lipping, these gaskets cannot get compressed, and the gasket gets an offset, and the gasket sometimes get also loosened, or it gets dislodged also. Now these gaskets are fixed by glues on the segments. If the gasket is not properly fixed, when you are lowering the segment, it can get loosened also. So that is why nowadays several countries they are adopting cast in situ gaskets. So the gasket comes with the uh, segment mold also. So it does not needs to be not fitted separately. Now the EPDM can be a composite, it can be a single or it can be a composite. So it can be with a hydrophilic gasket also. Now there are different types of tests by which you can check what is the compressive load of the segment, what is the closure of the segment. There is a standard curves as provided by the manufacturer. So whenever the EPDM gasket is coming to the designer checks as per the what is the contractual specification, and whatever the supplier has given, he has to check all the specifications of the gasket. So there is a standard curve according to the compression load. What will be the closure of the gasket? You need to check, and there is also you need to provide a test certificate also. Because the gaskets are designed for a certain water bar pressure. So, what is the water bar of the water pressure you are expecting in the gasket? You need to specify. So that is I told you earlier. For the gasket, there is a certain tolerance. So this is the standard tolerances we generally provide, and these gaskets are designed for 100 years because our tunnel lining has a design life of 100 years. So for the 100 years, what is the gasket relaxation? What is the factor of safety of the gasket? Everything you need to check in terms of the design aspects. Now this is the segment general arrangement. So if I take a 5+1 ring, so you can see there are we have total 6 rings, including the key portion. So this is the complete ring. After once all the rings has been joined, this is the complete ring, and you can see that the bolts has been installed. So when you are seeing along the length of the segment, so you can see only one type of the bolt you can see, because the longitudinal bolt you cannot see here. So this is the universal tapered ring, and all the ring dimensions you can see how they are placed also. So this is the general arrangement along the length of the segment, how the rings get connected one by one and how the rings are built one accordingly. This is the segment general arrangement. So this is the how the two segments are being joined by the bolts. So this bolt groove is already been defined in your mold. So the mold already is defined. So whenever you are here, this is the bolt. This is the mold. So in the mold, you can see already there is a groove of the bolt. So you have to when you are casting, this groove is already being it is being formed along, and this is the reinforcement you are putting. So this is the mold where you are putting the reinforcement, and in the after the reinforcement, the concrete has been poured, and then it is cured. It is basically steam curing. After that, it is demolded, and then it is stacked. Now, there are two types of reinforcement that we are putting. One is the circumferential reinforcement, one is the longitudinal reinforcement, and there are also U bars or the link bars we are putting. But main thing that whatever the reinforcement arrangement you are putting, we are mostly concerned about the edge of the segment, because in the edge we are getting the thrust of the segment. So here there should be sufficient reinforcement so that the segment does not get cracked. And another thing is that whenever the reinforcement is going above this bolt pocket, you need to provide sufficient cover. Now, this one of the big example in initially in Lucknow Metro, when they are doing the first phase of the TBM project, there we got a cover of I think the cover was less than 25 mm, because at the bolt pocket there is a codal specification that the bolt cover should be minimum 25 mm with the with a plastic sheet, that all your reinforcement should be encased in a plastic sheet. So here we got a cover less than 20, it was around 17-18 mm. So client raised the objection that in this portion, the durability of the segments will not be ensured, because if you have a very less cover, because the cover as per the standard our metro project, it is I think for 40 mm at the intrados and 50 mm at the extrados. So here we are getting a cover of less than around 20 or 17-18 mm. So then it was raised an objection, or it has provided an NCR that at this portion the cover is minimum, so it will be a question of the durability of the reinforcement bars. So what we did, we checked the durability according to the exposure class of the ground, or exposure class of the whatever the chemicals that is lying in the ground. And as per the standard British codes, we proved that the exposure class is not very highly aggressive. So it will not affect the segment durability. So this is the when the segments are being placed. So this is the portion where we are putting the. You can see this is the black line. So this is the hydrophilic seal or the gasket is being placed. So you can here what you are doing. Both the hydrophilic seal and both the segment gaskets are. So it is a composite portion. This is the portion of the first where the segment is putting the jacks. So we are putting here some plyboards here. So so the directly the bearing area of the segment is not getting affected. This is the segment mold. The segment mold comes from the segment. The segment mold is coming separately. So in the segment mold, there is a different type of the segment. So you can see this is a C type, K type, B type. This is the different according to the numbering of the segments or what is the configuration of the segment. The mold is coming. Now the designer needs to check the mold dimensions that the mold dimensions are compatible with the segment general arrangement. So if this is your segment general arrangement. So this is the segment general arrangement. You need to check with all the mold dimensions that the mold have the sufficient tolerances or all the dimensions of my final segment lining, they are compatible with the mold dimension. So for each type of segment, there are separate molds. Now these molds are put in the segment factory. So we are making a separate segment production factory or segment casting factory in any TBM project where the segments are being manufactured. Now, before starting of the project, you have to manufacture sufficient number of segments or sufficient number of segments should be ready so that during the movement of the TBM, you have sufficient segments to be filled. This is the segment mold where you are putting the reinforcement. You can see the bolt pockets also. You can see the erector or the lifting socket also. This is the segment casting factory. So here you can see there are lots of segments and this in the right hand side, this is the vacuum pad by which the segment is being lifted. After the casting of the segment, once it has gained the strength, we are lifting the segment by the vacuum pad. And this is the stacking of the segment. So the segments are stacked here. Between the segments, each segment you can see there is some sort of wooden planks are placed. So the one segment is not directly contact with each other. So all the loads are getting distributed to the wooden planks. So the loads are not getting directly in contact between the segments. And this is the complete ring after it is being built. One complete ring with the key piece. It is being built. Okay. Anyone have any question till here? Because after that, I will discuss the design principles. So this is all the component of the segments we are mostly dealing here.
Sir, actually, durability in Delhi Metro or others, Kolkata, Mumbai, all they are saying 120 years.
Yes,
But
yes, yes.
120 years durability, EN code also not supporting. They are saying 100 years. So how it
Yes.
can be negotiated? 100 years durability code is referring and contract is
Mm,
asking 120 years.
Nowadays, actually, in Indian Railways RDSO guideline, all the metros have been made for 100 years. I agree with you. Initially, it was 120 years, but nowadays, the RDSO, the Indian Railways Board, they have agreed that it should be 100 years. But whether it is 100 years or whether it is 120 years, you need to check the exposure that I show you here. Yeah. For the durability, what is the main thing that one of the things is that the reinforcement should not get corroded by your chloride attack, by carbonation, sulfate, acid, and alkali reaction, or if there is any frost attack or spray current protection. So all these things you need to check as per the British codes or the EN codes that what is your durability limit. So according to the durability limit, there are different exposure classes. So what is your particular exposure class? It depends on because in Lucknow it might be different, in Calcutta it might be different. So for all the exposure class and as per the structural class, so what you are doing, we are specifying the what is mean by minimum cement content or what will be my minimum strength content. What is the minimum compressive strength of the concrete? I will specify. So this is the requirement of the concrete as per the ACI 318. This is the standard exposure class. And also if it is 100 years or if it is 120 years, there is a I think there is a Life 365 software we did in Ahmedabad Metro. We run through this software because the mix design, whatever the contractor is specifying, that mix design, we provide the inputs, the cement content, that is the uh, what is the grade of compressive strength of the concrete. All these inputs we provide, and then the software runs and it provides what is the durability you can achieve. So it depends on your exposure class. If you are going with a 120 years, if you are going with a 100 year, what is the current exposure class as per the chemicals that is lying in the groundwater or in the soil? And if you are in, according the recommendation, whatever the mix design you are making, then mix design needs to be compatible with the standard software, and that will predict your uh, design life of the structure. But mostly nowadays we are going with a 100-year design life.
Okay, sir.
But if you are interested, I can forward you the what we did in Ahmedabad Metro. We made a separate durability report. So what happens in the segment design for the as apart from the structural design, the designer has to specify what is the fire design, and another thing is the durability. That is the DART report. So in the durability report, he details very detailed. He provides that how is ensuring the 100-year design life or 120-year design life based on the groundwater characteristics, and also the mix design that the contractor is specifying, and what is the minimum cement content, what is the minimum compressive strength, what is the exposure class. So all these inputs, so he runs through the standard software, and he demonstrates that the design life is more than 120 years. So in our metro Ahmedabad Metro project, as per the AFCON's standard mix design and whatever the chemical and the groundwater results we got from the GIR, when we compared this result and when we defined the exposure class, in I think we got a design life of around 250 or 300 years. I could not remember. It was more than 100 years. So that is after that the GC they approved the design, because once until the 100-year design life is not verified, your design is not complete or design cannot be validated.
Yeah, same also ISA has supported by Life 360 software in Mumbai
Yes,
Metro.
yes, yes, yes,
I think it
yes,
is
yes, yes.
170 years. But
Yes.
uh, based on that concrete mix design, yeah, cement content. But actually, sir, uh, yeah, apart from the software, that reference code and exposure condition, if I go 120 years, so means any kind of material, if we can change, there is any possibilities to prove apart from that Light 360 software.
So that is the exposure class you have to determine. No? From the ACI code, you have to determine the exposure class. First of all, exposure class, and accordingly, you have to determine what is your strength class. What is the minimum compressive strength, or what is the minimum cement content you will need to specify. That is the first of all. The software will come at a very later stage.
Hmm. Sir, another
Exposure
point,
class. Mhm,
like increasing the thickness of the segment, is there any
mhm.
possibilities to increase the life of the structure?
Uh, Thickness of the segment is mostly you can take durability, but also it another thing is for the fire resistance also we specify the thickness of the segment. You can increase it is increase, but what happens it is also the contractor obligation that what is the mold he's having. This question came in LNT one of the project because they were telling that our segment we the mold we have 325 mm, but our design was dictating 350 mm. So they told that we cannot change procure a separate mold, but it is right that if you increase the thickness of the segment, it will also govern your durability also.
Sir, same like
Because
Calcutta Metro under Hooghly River, I think it was 300 something, just river
yes,
part, rest
because
of the part 275. So that's why
exactly
there is a
because
some discussion initially, I remember, but after that
yes,
I
yes,
unable to recall that 300 millimeter below Ganga and rest of the part 275.
yes, because that part you will have more aggressive because here you have the water and also here you because you have to make the for the durability also you increase the cover also. So if you increase the thickness
Mm.
of the segment, that will also cover the
Yes,
durability part
yes.
of
Mm.
it.
Mm.
It is not uniform because, as I
Mm.
told you, when we are crossing the Haidarnala part in Lucknow Metro, that part we made a very special segment. So here we did not increase the thickness of the segment, but we all the reinforcement we made a epoxy coated reinforcement because in the Haidar canal it's a basically sewage canal. So here I will have the durability as a very aggressive ground because other part of the uh, part will have a very light or moderate type of exposure. But in the Haidar canal on the 18-20 meter, this part the client told that I want a very high exposure because my durability will be very critical. So we cannot change the thickness of the segment because already our molds is fixed. So what we did, all the reinforcement, we made it as a very epoxy coated. So it is already considering the durability aspect. There are also other aspects, as I told you earlier, in the bolt pocket where I am getting a very less cover. So there comes the durability part. So I cannot change the reinforcement arrangement because already my drawings has been approved or already I have started my production. So what we did here, we put a plastic sheet there. So the plastic sheet is taking into account of the durability part. So even there are alternative arrangement if you cannot change your reinforcement arrangement or you cannot change your thickness of the segment. But first of all, you need to prove your exposure class. That is most important. That what is the chlorides, what is the sulfates, what is the carbonate, or whatever the other alkaline reaction that is lying in your ground part. Then you need to confirm first as per the EN codes or as per the SCI code. Because nowadays in the segment design, SCI code is very important. American Concrete Institute, the latest code, the 318, it is the most detailed and most latest design code we are following. Or if you want to refer the British code, there is a PS guideline, that is the latest code we are following.
Sir, suppose exposure condition is very critical stage, maybe there is a salt content is huge. So in that
Mhm.
case, that minimum clear cover like 50 millimeter outside and inner side 40 millimeter. After
Mhm.
providing this, if I am not getting life 100 years, so what will be the recommendation to change of that material or to increase the cover or something else?
First of all, cover this 40-50, you cannot get uniform along your all part of the reinforcement. If you check, because the reinforcements are not straight, it is a curved reinforcement. You have the bolt pocket, you have the grout socket. So at several places, you will get several cover. And second thing is that if your exposure class is very high and already you have started production of the reinforcement, then either you make it as a epoxy coated or either you cover by a plastic sheet. Because you at the mid of the production stage, I cannot change the reinforcement arrangement. I can make additional reinforcement wherever I think that it might be get affected. I can put some additional chair bars or I can put some additional um, parts also. But generally, we try to make it as a epoxy coated, or I to try to make it within a plastic sheet cover.
So that plastic sheet cover, it is permanent or temporary?
It is considered as a permanent. Nowadays, also the bolts we are making permanent. Nowadays, there are
Okay.
ISO bolts that is called as a permanent bolts because
Mm.
initially all the initium tunnel bolts we consider temporary. Nowadays, the initium tunnel design they are considering the bolts as a permanent. These bolts are very special bolts, not as a SN bolt or as a SDA bolt. These bolts are very special bolt, but the bolts are covered in a plastic sheet. Plastic sheet means that is not our plastic what you are taking. It's a separate type of sheet, which is taking into account of the durability. That it prevents the exposure of the chemicals to the bolt this for the steel. In
Okay,
nowadays,
sir.
in several Middle East projects, they are using permanent bolts. So the bolt has a design life for around, I think, 50-60 years. It has a design life. So the manufacturer itself he is dictating that I my bolt has a design life of 50 to 60 years. So accordingly, he is making the arrangement.
Okay, sir.
So everything depends on your durability. So you need to check the durability report very well. Okay.
Okay.
Now as I told you earlier, whenever we are designing the segment, there are three stages. One is the production stage, one is the construction stage, one is the service stage. So the production stage is that when you are putting the reinforcement in the mold and the segment are being casted, then it is demolding. Demolding is basically we are removing the segment. So we are removing the segment by vacuum pad. So So here we are removing, this is the demolding operation. This is the molding operation where we are casting the segment in the molds. This is the demolding where you are removing the segment. Now, when you remove the segment, that is, there is also a certain minimum strength that is being specified by the designer. That there is a, if it is a M40 grade, M40 or M50 grade grade of the segment, so there will be minimum strength of around, I don't remember exactly, but there is a, in the DBR or the design basis report, the designer specified that if this strength is achieved by the concrete segment, then you can remove the segments. And next is the storage of the segments. So during the storage of the segments, also the strength is gained. So once also during the storage, you need to cure the segments, and then once the desired strength is achieved, then you can put the segments for the transportation. Transportation means you are taking the segments to the TBM shaft, and then you are lowering the segment. Next step is the handling of the segment. Handling of the segments means that you have to lower the segment. So there is a, as I told you earlier, there is a erector socket in the segment to which we are lowering the segment, and then these segments are being handled by the TBM. There is a robotic arm of the segment, robotic arm of the TBM through which these segments are being handled. Now, the segments are placed one by one. So there are four stages of the, one is the molding, demolding, storage, transportation, and handling. Now, all these stages, there will be a certain amount of forces developed. These forces can be a bending moment, this can be a axial force, this can be a shear force. Now you need to check all these forces, whatever the forces are developed or whatever the bending moment is developed. So accordingly, all the bending stresses are developed that is within the required strength. So the required strength we have specified in the left and right hand side. So in all these cases, the segments are within the achieved required compressive strength of the concrete, whatever you specify. So the segment does not get cracked, because if any type of eccentricity is developed during the handling or during the transportation, so it can develop cracks within the segment. So we need to take into account. Second is the construction stage. Once the segments are lowered and the segments are being placed by the TBM, and once the segment is completely, they are forming a ring. So the TBM is taking the from this segment, from the trailing leading edge of the segment, TBM is taking the thrust. So the segment is experiencing the TBM thrust for a temporary period. And this is the very critical period. If the TBM jacks are not properly placed on the segments, or there is some eccentricity of the jacks and the segment position, it can develop in tensile stresses. So we find that during the launching or during the TBM movement, or after the TBM has gone away, there are several segment gets cracked. Now the crack can be at different portions. Sometimes the cracks develop at the bolt pocket, sometimes the cracks develop at the trailing edge, sometimes at the leading edge, sometimes at the body of the segments. It depends on what is the nature of the cracks. So this, if these cracks are being developed during the TBM movement process, so you need to check that whatever the reinforcement you have put at the leading or the trailing edge, that are very sufficient. So they can take into account of the forces. And also you need to check whether the segment TBM jacks or the pads, they don't have the eccentricity, or if it has a eccentricity, it is within the tolerance limit. Now the next part is the grouting pressure. Once the segments are being pressed, we are doing a primary grouting as well as secondary grouting. Now this primary grouting and the secondary grouting, they are also inducing an additional pressure on the segment, but that is also temporary pressure. This is not a permanent pressure, but still this will create some additional moment or additional axial forces. So you need to check all this also, that whether these are within the tolerable limit. Now come the service stage. Service stage is that This is the permanent stage where the segment starts functioning or the segment starts taking the load. Now, what are the loads? First of all is the ground load, then is the groundwater load, and is the surcharge load. Ground load means that the whatever the ground where the segment I have installed. Groundwater load means whatever the groundwater condition I have, it might above the tunnel crown, it might lie below the tunnel crown, it might lie at the tunnel spring line. And the surcharge load means that if there is any structure above my tunnel alignment, if there any type of building, any type of superstructure, any type of factory, whatever the things, it can be also a temporary surcharge load of a construction load also. Then comes the longitudinal joint busting load. This is a very important. I'll just show you here. Yeah. Longitudinal joint busting loads means at the joints when the TBM is putting the thrust here, there might be chances of the busting of the edges, or might be that due to the tensile stresses, there can be some busting stresses developed. So these stresses you need to check also that whatever the reinforcement you have provided, whether they are able to take the TBM thrust load. So this is called the TBM busting load. And And also there can be load due to additional distortion. It can be due to earthquake also. There will be fire load. There will be explosion load. Nowadays we are also taking into account of the explosion load. If there's any type of explosion, any type of terrorist attack within my TBM, or any type of certain explosion happens. So this is also we are taking into account. We are taking into account also of the mechanical load, electrical load, railway load, temperature load. So all these type of loads comes on the service stage. So all the TVM segments are designed for the three stages. Now this is for the production and the transient stages. As I told you earlier, there will be one molding of the segments, there will be demolding of the or the stripping of the segments, then there will be stacking of the segments, then there will be transportation of the segments. For all these stages, you need to check whatever the bending moments has been developed in the temporary stage, and how you are lifting the segments also. So whether your lifting arrangement is creating any additional eccentricity also, that you need to check. So for this, all the forces you need to check, and you need to provide that your reinforcement arrangement is able to take care of these additional forces. So these are the standard formulas by which we can determine the bending moment and shear force. And this bending moment and shear force needs to be checked as per my structural capacity of the segment. So this is the production and the transient stages forces that needs to be compatible with my reinforcement arrangement. Now, this is the tolerance in the segments, because every segments there will be certain amount of the tolerance. So this tolerance can be what will be the tolerance for the segment, what will be the tolerance for the joints, what will be the tolerance for the gaskets, what will be the tolerance of the closed ring dimensions, and even if there is a stepping and leaping also, what will be the maximum amount of tolerance, what will be the gap between the contact faces. So all these tolerances you can find whenever you are dealing in any metro project. In your construction specification, these tolerances are being specified by the client as their contract condition. So after the production of the segments or after the installation of the segments, you need to check that these tolerances are being validated. So that is why after the full segments has been developed or all the segments has been in place in the regular survey data, you can check that whether these tolerances are within the limit. If it is not within the limit, then you have to take some precautionary action. Now this is for the construction stage. So previously we have this stage we have discussed about the production and the transient stage. Now we come to the construction stage. So in the construction stage, what is happening that the TBM is taking the jacking thrust on the segments. This is in the slurry machine or the EPB machine, they are always taking the thrust of the segment. But if it is a rock TBM, if it is a gripper TBM, it is not taking the thrust from the TBM, it is taking from the rock face. So in our current TBM that we are using in the metro projects, all the thrusts are being taken on the of the segment. So the circumferential face of the segment, it is getting the thrust. So due to the thrust at the face of the leading edge of the segments, so whatever the reinforcement that is taking into account of the thrust. So here, whatever the stresses are produced, you need to check that whether these stresses are within tolerable limits. Sometimes what happens that these jacking pads are not perfectly aligned with the segment center line or the segment edge, and there can be certain amount of eccentricity developed that can produce certain amount of cracks also, certain amount of tensile stresses also, certain amount of distortion of the segments also. So this is one of the cause of the development of cracks in the segment. This is the basically the formula by which we can determine the bursting tensile forces, and accordingly you can check what is the tensile stresses developed. So whatever the tensile stresses are being developed, that can be compared with the, as per whatever the codes you are using, what is the allowable tensile strength of the concrete you are using. Now we come to the construction stages. In the construction stages, we are doing the tail end grouting. The grouting after the installation of the segments is always done from the tail end of the TBM. So the tail end of the grouting, what we are doing, we are basically filling the gap between the excavation phase and the segment, because there is a gap between the excavation phase and the segment. So that is creating the volume loss. So to cater for the volume loss or to close the gap, we are doing the grouting. Now the grouting can be primary grouting, it can be secondary grouting also. The primary grouting is done immediately after the installation of the segment. That will fill the gap, and that will also make the segment as a watertight, because we have a gasket, but also we are doing the grouting so that any type of groundwater flow cannot occur. So if I feel that after the grouting is being done, my primary grouting is done, but still I'm getting some water ingress or some sort of seepage from the bolt pockets or from the joints, we are doing a additional secondary grouting. Now this grouting can also create a additional thrust, and mostly it creates the thrust on the ground portion of the segment. So this is also a very temporary load, and it is also a part of the construction stage. So we are checking whatever the bending moment is being developed on that particular part where the grouting load or grouting is being accumulated, that part. So we are checking the bending moment, and we are defining that in the construction stage, my segment for the particular grade of the concrete, for the particular compressive strength or tensile strength, whatever the reinforcement arrangement we have provided, that is fine. So up to this, we have defined all the construction stage and all our production stage loads. Okay. Anyone have any doubt or anything not clear?
Sir, I have a two question.
Yes.
One is the blasting reinforcement coming from the jack thrust, or sometimes there is a high-rise building. Suppose normal greenfield area maybe 10 meter, 12 meter yeah, filling from the tunnel, but
Mhm.
sometimes there is a high-rise building, maybe G plus 100, G plus 50 something.
Yes,
So
yes,
that
yes.
blasting reinforcement,
Hmm.
how it will become?
The busting enforcement basically TBM jack thrust. It is not to do with the building. The building will take into account of the surcharge load. The building load, whatever you are telling, even if I have a G plus 5-story building, in future I can have a provision of making it a G plus 20-story building that will come on the surcharge load. Busting reinforcement is only for the taking into account of the segment thrust, jacking thrust only. It's a
So that means
temporary
that,
part.
so that
Mm.
means that additional load. So is
Mm.
there will be any impact of the that main bar of the segment, like what
Exactly.
we are using normally? Yeah,
Yes, yes.
kitna,
That will
10
come in the
numbers.
service stage. That will come in the service stage. That whatever the reinforcement have been placed. So when I am making the combination, load combination, there I will consider it.
Sir,
Because
then
this,
then ground settlement. Suppose
mm,
if TBM cross normal area G plus 5 building something, and TBM cross G plus 50 building area. So what will be the governing factor for TBM operating in that area?
depends on the ground cover also. What is the amount of the ground cover I am getting also there. And
So that means you are
it is
saying
also
phase pressure.
not face pressure. It is basically the ground cover. Another is the spindleness ratio of the building. Because if the building is very high, that can create additional tensile stress in the building due to the TBM movement. That is checked in the building damage assessment. What you are telling. If I have a suppose if I have a tunnel and my ground cover is 20 meters. Now if I have a case of G plus 5 building and another I have a case of G plus 20-story building, The G plus 20 story building is more slender compared to G plus 5 building because of the height. So what happens, whatever the TBM volume loss it happens, it is 0.5%, 0.75%. So whatever the ground movement that is the TBM inducing, so the same movement will be induced in both the buildings. In the G plus 5 building, the impact will be less compared to G plus 20 because the G plus 20 building is more slender. So there will, due to the settlement induced at the foundation, I will have more amount of the tensile stress if it is if it is moderate category. So that is why if it is a G plus 1 story building and if it is a G plus 5 story building, G plus 1 story building is not vulnerable to the TBM movement. Because whenever we are checking the building health, we check in terms of the tensile cracks develop in the building. That is the building damage assessment. In the Berlin criteria, we are checking what is the thickness of the crack or what category it is coming. If it is coming in a moderate category, then it is very vulnerable to be. But if it is whatever the building you are specifying, if it is taking in the TBM reinforcement, it is coming in the surcharge load. Now, one interesting thing is that in the segment design, all this production and the construction stage are not coming in the permanent. It is only during the temporary stage. Now, whenever you are considering the service stages, these service stages loads are they are combined. Combined means they have a certain partial factor of safety. So if it is a ULS condition, so for the dead load, surcharge load, groundwater load, we are taking a partial factor of safety of 1.5. If it is an earthquake load, we are taking a partial factor of safety of 1. If it is SLS condition, we'll taking a partial factor of safety 1. So whether any type of building structure, whether it is any factory, whether it is any stacking structure, all this load comes under surcharge load. That is nothing to do with the busting. Busting is only part of the TBM installation, segment installation or the TBM movement. That time we are taking the busting spaces.
Sir,
Is it? Hmm.
in which case we are using ladder bar of the segment?
Ladder bar generally we use whenever in the part of the we take that is the wherever chair bars or the ladder bars we are providing more at the ground erector part where we are the part where we erect the segment, that part we are mostly providing the ladder bars.
Yeah.
Because
My
this
last question
segment
is, sir.
no, first of all,
Yeah.
this segment arrangement, as I told you earlier, there will be two type of reinforcement. One is the longitudinal, one is the circumference. So there is the main bar, there is the secondary bar, then there are the stirrups. Apart from this, we are providing additional bars. One is for the when the segment is erected, when the segment is being lifted, then we are providing additional chair bars. Another type of segment we are providing at the trailing edge or the leading edge where the segment is coming into contact with the segment TBM jacks. This is the additional reinforcement. This is not part of the permanent reinforcement. This is part of the taking into account of the temporary loads. So in the segment, if you consider that the quantity, if you consider only the main reinforcement, might be the quantity is 85 kg per cubic meter. But finally, the quantity goes to 100, 115 kg per cubic meter because we are considering some additional bars to prevent cracking in the segment at the edge of the segment. Whenever the segment is being lifted, also that part also, whatever the additional moment, that is taking into account by this additional reinforcement. So whenever the designer is calculating the reinforcement in terms of the design the main reinforcement quantity, and when he's giving you the final quantity, 25% automatically increase. So in the GeoConsole, whenever we are doing the design of the segments, so when you are taking in the suppose in a pre-bid project you are doing, so in the pre-bid project the client or the contractor tells me that I have a limit of 90 kg per cubic meter. So 90 kg means that it is including all the main reinforcement, including the secondary reinforcement, all these chair bars, ladder bars, and your busting reinforcement, everything you have to combine it. So your design should be in such a way that all the reinforcement you have to combine. This is not the same case when you are designing a beam and column. In the beam and column, you have already main reinforcement and the secondary reinforcement. In TBM, it's a completely different because TBM, the main reinforcement takes into account of the service load. Service load means the dead load, the water load, the surcharge load, the earthquake load, the fire load, then your explosion load, whatever the load is. But additional 25%, 30% this reinforcement, it's taking into account of the production stage and the handling stages. So that is the additional reinforcement you have provided. So whenever the reinforcement arrangement drawing is coming, you need to plead the reinforcement, then you can understand how these reinforcement are being placed.
Okay, sir. Okay. Sir, my last question, grouting strength. So grouting
Mhm.
strength, how we can calculate? It is totally depend on the surcharge load or some minimum strength, or it is related with the concrete compressive strength, something.
Routing actually it depends on your purpose. Grouting strength is basically depends on your purpose, but apart from the grouting strength, sometimes people see the grouting pressure also. Now, if you take into terms of the grouting pressure, there is a thumb rule that whatever is your ground cover, so per meter ground cover, it should be 0.1 bar. So if I have a 18-meter ground cover, that means it should be 1.8 bar pressure. If it is a 350-meter ground cover, that means 35 bar pressure. Now, all our metro projects is generally at a very shallow cover. We have a 50 to 20-meter depth. So our grouting pressure varies between 1.5 to 2 bar. Generally, sometimes 0.5 bar, 1 bar pressure we are providing. But this TBM, these grouts are mostly for backfill grouts. So we are not going very high compressive strength grout because we are just filling the gap between the excavated face and the segment at the tail end. If you need a very good grout for a water ingress cutoff, then you need a very high compressive strength grout, or you need a very high pressure grouting. It depends on the purpose. But in TBM, it's a mostly the backfill grout. It's nothing with the uh, improving the strength of the material.
Okay.
Sir, I have few questions.
Yes, yes, please.
Sir, before the primary grout, due
Mhm.
to the overcut, there is no
Mhm.
contact between the TBM and the grout. So
Yes,
when
yes.
we are checking the primary, designing for the primary grout, what type of support
Mhm.
system we are providing? We are spring or how to model that?
I don't understand your question. What you are telling?
Sir, actually, in the primary grout condition, there is no
Mhm.
ground contact because the overcut,
Yes,
right?
yes. Yes, yes, yes.
But when we are modeling the TBM as a your weighted beam approach, there is
Mhm.
some spring we have to assign, right? So
Yes, yes, yes.
how to model the TBM in primary grout condition?
Actually, in my project, what I did, I just put the load only. That is this amount, this type of. I just show you this in the my STAD model. Just I put this localized grout pressure only, and I calculate as a separate stage. The grouting load I consider as a separate stage, not in my main analysis. Just as a localized 100 kPa pressure, I put here on the only the crown part for a certain portion of this. But in the finite element model, you can interface it. You can put a interface, and then you can define the gap between the excavated face and your segment face, and that will take care of your uh, gap also, whatever you are asking.
Okay. Sir,
If
another
you if you
question.
take a if you take a RS2 model, what we do when the if it is a segment, so we are putting an interface between the segment and the ground. So particular at that portion, if you can define your interface. So at that interface, if you want that if there is no contact, so you can define what are the interface properties. So it will automatically take into account of that part. It's basically the interface you have to define.
Okay. Sir, one more question. Can you
Mhm.
elaborate the additional distortion one load combination is there?
Yes, yes,
Additional.
that I will specify to you. Tell specify. Okay. Now this is the final or the service stages because our segments production has been over. Also, our segments has been installed. Now, once the segments, all the segments and all the ring has been completely built, now the all the final loads will come. Now the ground load will come. So the ground load means the whatever the ground cover. Then it will the groundwater. Just 1 minute. So groundwater means that what is your groundwater level? Now the groundwater can be above the tunnel ground, it can be at the spring line, or it can be below the uh, tunnel spring line, or it can be below the invert of the tunnel. Now this is a very critical condition when you are using Murud method. In Murud method, if the groundwater is above the ground, it is a favorable condition. You will have a very balanced loading condition. The groundwater more goes below the invert, the bending moment increase, and it is a very critical condition of the segment. So that is why in the metro project you see there are two type of water levels specified. One is the highest water table, that is the whatever your groundwater level plus 1 meter. If your groundwater is at the ground surface, the ground surface plus 1 meter additional. So that is the most favorable condition of the segment or most favorable structural condition of the segment. The most vulnerable condition is that when the groundwater is going below the invert level. So that is why in the metro project we are specifying invert level minus 3 meter. So there, the most dry condition, you have a very high bending moment and you have a low axial force. So when the water load is very high, you have a high axial force, low bending moment. If you have a groundwater level below your invert, you have a high bending moment and low axial force. So in the MN curve, when you plot in both this groundwater table condition, in the high water table, your MN curve will mostly in the axial part. The bending part will be less. But if the groundwater table is below the invert, your axial parts will be less, but the bending part will be high. So that is why you are taking the both high water condition and the low water condition. Then comes the surcharge. So, okay, we'll just take a half an hour break and then again we'll start at 10:30. Okay?
Okay, sir. Okay.
Okay, okay.
Okay, so in the final service stage, we have discussed about the ground, we have discussed about the groundwater. Now we come to the surcharge part. In the surcharge part, basically it's the load that is lying above the ground. So it can be a building load, it can be a superstructure load. So you have to consider for the particular amount of the surcharge. So sometimes in the metro project, we are specifying 40 kPa surcharge, we are specifying 50 kPa surcharge. So this amount of surcharge considers that whatever the building number of stories you are considering, so that is being governed by that load. So directly on the tunnel alignment, if there is any building or away from the tunnel alignment, is there any building? So maximum amount of the surcharge needs to take into account. So it can vary. It can be up to 100 kPa surcharge sometimes we are considering. Now, next is the hoof force transport along the longitudinal joint between the segment, because the segment is a perfect circle. So here the forces are mostly compressive. The segment does not takes into account very small amount of the tensile forces. So all these thrusts are called hook thrusts. So the hook thrusts are basically the thrust that is being transferred between the segments. Additional distortion means that there is a limit of the deformation or limit of the distortion of the segment that is around 25 mm. So if there is an additional distortion or additional movement due to the ground loading or due to the distortion of the segment, that is also creating additional moment in the segments. So that is the additional distortion. That is mostly we check the distortion of the segment or whatever the allowable limit of the deformation of the segments on the diameter part. So that is the additional distortion part. Earthquake is only applicable for segments that is coming in the very shallow covered tunnel. If it is a very deep covered tunnel, we are not taking into account of the earthquake. Earthquake loads are additional loads apart from the static loads. There will be also a fire load, and fire loads are very important nowadays because all your segments needs to be fireproof, or whatever the segment thickness you are providing, that need to be compatible with the fire guidance. So if it is a 275 mm thickness, or if it is a 350 mm thickness, that should need to take into account of the fire load, the temperature that will be generated, the amount of the heat energy that will be generated in joules. So that will take into account of the whatever the segment thickness that will be affected, but still the balanced thickness that will be left, that will take into account of the design life of the segment. There can be explosion load. Explosion load is mostly that if there any type of explosion within the tunnel, so that explosion load is an additional load that is also taken into account in the segment design. If there is any additional tunnel or any already constructed tunnel running along parallel to your newly tunnel, so that constructed tunnel segments or whatever the lining, that load effect that is coming to your newly constructed tunnel, that is also being taken into account. So this is mostly the loads we are taking in the final design stages. And this is the diagram where we are defining the surcharge load, we are defining the water load, the water thrust, the earth pressure, the buoyancy load, everything we are defining here. Okay. Anyone have any doubt? Now we come to the longitudinal joint busting load that I told, that all these hoop thrusts that is being developed due to the permanent earth pressure and the groundwater pressure that is transferred from segment to segment. Now here we are getting a reduced cross-sectional area of the segment. Reduced cross-sectional area of the segment, why we are getting? Because the segments you are taking when there is a groove where we are putting the gaskets. There is a groove that I show you here. If you see the segment general arrangement, yes, this is the segment. Whenever you are seeing the general arrangement between the two segments, there is a group, small group, where we are putting the segment gaskets. So there is a slightly reduced cross-sectional area compared to the original, whatever the arrangement of the segment we are considering. And for that, we are taking into account of the busting thrust whenever the TBM jacks are in position. So at that part, whatever the tensile stresses that is being developed in the ULS condition, we are taking into account of these tensile stresses, and we are comparing with the tensile strength of the concrete. So basically, there are two types of condition. One, when we are considering the permanent loading stage, here another thing is that the moment of inertia that you are considering, that is also reduced moment of inertia. That is not the original moment of inertia of the section, because the segments are connected through joints. So if it is a 5+1, if it is a 6+1, number of the segments accordingly, the moment of inertia is also reduced. So there is another one thing is the reduction of the moment of inertia. Another one is the reduction of the area of the segment or cross-sectional area of the segment, particularly where the groups are there for the stress relief or where the gaskets are being present. So these, in this portion, there is a chances of the spalling of the segments, or there is a chances of the high tensile stresses developed when the TBM jack thrust or the jack pads are being put here. So this is one of the conditions we are considering in the final service stages. There is the joint busting load. Now comes the additional distortion. Additional distortion is basically when the segments are in place. There might be some movements also that can be due to the misalignment, that due to the connectors also, that can be due to the excessive ground pressure also, might be some additional ground movement also, or might be due to the some additional tunnel that is going along the new tunnel. So there can be some additional distortion. This additional distortion we generally consider in our metro project it is around 25 as I remember, but in international projects they sometimes consider 15 on the diameter. Now this additional distortion has a very interesting effect that is called bird's mouthing. This bird's mouthing is a very common phenomenon, or is a very one of the most important phenomenon that you need to check before your segments are being placed, or even after your segments are being placed. There is a chances of developing a bird's mouthing. Bird's mouthing means that between the two segments there is a gap develop, and that looks like a shape of the bird mouth. So during the segment testing, whenever we are testing the segments, or whenever the universal ring is being built, we are checking the bird's mouthing effect. So whenever you are putting the loads on the segment, before putting the segments onto the shaft, you are taking a load testing of the segment. So that time, whatever the bird's mouthing effect has been developed, that should be, or whatever the joint closure has been developed, that you need to check whether it is in the tolerance level. So basically, the load induced due to additional distortion is called the bird's mouthing. So the bird's mouthing means that the joints are not perfectly closed, and the joint there is an additional gap, so that will create an additional moment also. So because this is an additional uh, eccentricity also, so this eccentricity causes a additional moment that is also taken into account for the final service stage of the segments. And next is the fire loads. Okay, anyone have any question on this previous part?
Is this bird's mouth thing checked on longitudinal side or circumferential joints?
Can you please be loud? I cannot hear you.
Sir, is this bird's mouth thing checked on this longitudinal joint or circumferential joint?
It is generally checked on the longitudinal joint. Along the longitudinal joint, it is generally checked. But it is being checked before, it is preferably to check before you install the segments. In one of the project, it was client criteria that you need to load test your segment, that whatever is the load carrying capacity of the segment, you need to check the load testing. And that time we found that our bird mouthing, whatever the joint closure, it was not satisfied.
Okay, got it.
Because the segments that you are producing, theoretically it looks very perfect, because sometimes there might be some tolerances, some misalignment of the molds also during handling, or also during your production stage. So all these things are needs to be checked before you put the segment in your tunnel, because once you put the segment in your tunnel and this bud mouthing is being found, then it's a very you can take, it's out of design, because once it is placed, it is very difficult to rectify. You cannot remove that part of the segment. So it is preferable that you check this bird's mouthing or your joint closure or whatever your misalignment of the segment before you put the segment to the tunnel. Now, very important thing is the fire load. Nowadays, all the road tunnels, railway tunnels, metro tunnels, they are just behind the fire, because nowadays the fire has been a very important in a tunnel design, because the segment thickness is governed by the fire load also, because whatever the fire load, it depends on whatever the temperature and what is your exposure of the fire. It can be 30 minutes fire, it can be 45 minutes fire, because once the fire has been initiated, there will be some arrangement to uh, not to allow the fire to spread in a very chaotic way. There may be misarrangement, there might be some ventilation fans also, there will be some other arrangements also, but still some exposure to your segment will be get exposed to the fire. Now the mostly the inner part of the segment gets exposed to the fire. Our introduced part of the segment is getting exposed to the fire. Now there is an IS code guideline in our IS 456. It specifies that our minimum segment thickness or minimum thickness of the wall should be 240 for a 4-hour fire rating. 4-hour fire rating means that whatever the segment you are designing or whatever the cross passage firewall you are designing, up to 4 hours it is able to handle the fire load. Beyond 4 hours, it will melt. So up to 4-hour fire rating, the segment thickness is minimum is 240 So our segment thickness, whatever you are proposing, 275 in metro projects, it gets automatically satisfied. Now, previously, what people used to do, all the designer, they used to specify this IS code specification for the cover requirement, that whatever the cover I am putting, that will take into account of my fire load. But nowadays, the client or the independent engineer, they mostly tell that you need to develop your own fire curve, or you need to follow the fire guidelines. Now, in our Indian standard, there is no fire standards. We are following mostly the European thematic network, or for metro tunnels, we are following the NFPA guideline. For road tunnels, we are following NFPA 502. NFPA is the National Fire Protection Association. So there are different types of fire curves. You can see there are 4 types of fire curves. So I have given one example. Suppose I have a 1000-degree temperature fire. So once the fire is caught, so you can see there is a steep increase in the temperature, then it is a static, then is a decline in the fire, because once the fire has been started, there will be arrangement to take into account of the fire, not to spread it in a very rapid way. So the exposure of the fire, in my case, in this case, it is 45 minutes. Now, after the fire loads is there, so it depends on that. There are 4 type of fire curves. So from the 4 type of the fire curves, we are mostly taking the ISO 834. That is the 4-hour fire curves we are considering. And these fire curves, from there, we determine that what is my temperature, or what is the duration of the fire, and accordingly, what is my temperature. So if it is a 4-hour fire curves, mostly you are taking a 4 hours is the maximum limit of my fire duration. So these are the tables depending on the thickness of the segments, what will be the exposed surface. Because if it is a 275 mm thickness segment, might be 30 or 40 mm only gets exposed. The rest of the segments, thickness of the segment is intact. So this is a standard curve. So from 60 mm to 240 mm, you can see for different temperature profile, it gives what is the exposed thickness. So in my case, we have developed a fire curve for 300 mm thick lining, and for a particular around of temperature, we found that it was around 46 mm. So 46 or 47 mm means from 300 mm we deduct is 250 mm. So 253 mm, if the fire is getting 43 mm or 47 mm is getting affected, so 250 mm is the balance. So that will be taken into account of my balance load or the balance service line. So I have to check for a fire load. I have to check that if the fire is getting my segments is getting affected due to fire, so the reduced thickness will take into account of all the loads, all the service loads, all the distortion loads, all the earthquake loads. So this is a very special case where we are checking that all the loads are being taken into account by the reduced thickness of the segment. And here we are considering a partial factor of safety of 1. In other cases, for all the other loads, we are considering a partial factor of safety of 1.5. But in fire, we are considering only 1. And only the bottom part of the tunnel, that is the your inner part of the segment, is only getting affected. Now we come to the seismic loading. Now, seismic loading is only applicable for the shallow cover tunnel. If it is a very deep cover tunnel, because of the ground stiffness, because of the ground confinement, we don't take into account of the seismic. So seismic is applicable only in the shallow cover tunnel, that is in the metro tunnels, because they are at a very shallow depth. Or if it is a NATM tunnel, we are taking into account of the seismic load only in the portal part of the tunnel. Because in the main tunnel, where it is in a very deep cover region, in an ATM tunnel, we are not considering the seismic loads. Similarly, if your segmental tunnel or TBM tunnel is at a very high covered zone, we do not take into account of the seismic. Now, the seismic, initially, we used to define the zone or where the region we are working. So if it is a northeastern region, it is a zone 5. If it is Calcutta, if it is Delhi, if it is Lucknow, it has different zones. From the zones, we used to define what are the seismic coefficients. So we used to define a horizontal seismic coefficient. We used to define a vertical seismic coefficient, and this seismic coefficient we used to define in our numerical analysis or in your STAT model, and you used to define the seismic loads. But nowadays, it is mandatory that you have to define your seismic load separately. So you cannot use the seismic coefficient because you have to take into account of the ovaling effect and the racking effect, because due to the seismic there might be ovalization of the segmental lining, or there might be lateral shifting of the segmental lining depending on your frequency of the wave or how the waves are transmitting through the ground. So the ground stiffness or the shear of velocity, there are lots of factors. So previously our seismic was based on the seismic coefficient, but nowadays we are taking into account of the axial and the curvature deformation as well as the ovaling and the racking deformation. So we are taking into account of the seismic response of the ground. So you have to need to do a very detailed seismic analysis. So for the seismic analysis nowadays we are using the hashish formula. This is the ITA guideline, one of the publications, seismic design analysis of underground structure. There is another publication by Wang, as it is called the seismic design of the underground structures. These two codes are very popular in the underground structure seismic design. Now, in the seismic, there are two types of earthquakes. One is called the maximum design earthquake. Another one is called the operating design earthquake. Maximum design earthquake is the very critical event that is very rare. It has a probability of 3 to 4% that it can occur in 100 years once at a time. It can occur 1,000 years once at a time. So it has a very low probability, but it's a maximum design earthquake. Suppose if a tsunami comes with a Richter scale of 7.8 or 8, so it is a maximum design earthquake. But normally earthquakes are coming every month, sometimes at a Richter scale of 2, 3, 4. So this is the operating design earthquake. So mostly we are designing both for operating design and most an MD case also. But the operating design earthquake means that it has a probability of exceedance of 40 to 50%. So our all segments are designed for operating design earthquake as well maximum design earthquake. But whenever you are considering the maximum design earthquake, we are not putting any additional factor of safety. So all for dead load, overburden load, hydrostatic load, seismic load, it is a factor of safety of 1. If it is an operating design earthquake, we are putting a factor of safety of 1.2. Now, can anyone tell me what is the reason for putting this additional factor of safety?
I guess load reversals.
But can you be loud, please? I cannot hear you.
Sir, because in case of earthquakes, our loads do reverse, maybe because of that.
No, not only I'm asking that in any type of design, structural design, you are always putting additional factors. In Eurocodes, we are putting partial factor of safety. In IS code, we have partial factor of safety. In any codes you see, we are putting a partial factor of safety. Sometimes it is 1.5, 1.3. Why you are putting partial factor of safety?
Take the account of uncertainty of predicting the load accurately.
Exactly. Because the design, what you are doing, we are doing in a day studies because you have a very limited amount of ground parameters. You have a limited knowledge of your ground, and whatever the parameters you are considering, it is in a 2D because you are not considering the whole area. So if you are considering a 3 kilometer tunnel, you are designing in a per meter cross section. You are not designing as a 2 kilometer tunnel. What is the total variability in the geology, ground condition, building loads, everything. So that is taken into account of the partial factor of safety, or that is the factor of safety you have. So if you are designing a structure for a 10 rupees, but your original design is valid for 25 rupees because 2.5 tons you have taken into additional load. So that is the thing that the structure will not collapse. So that is why any type of non-engineering person, he will always ask you, okay, whatever you have designed, whether the structure will not collapse, you can ensure. So you can ensure if your partial factor of safety has been taken. So in the MN curve also, we are putting partial factor of safety against concrete, steel. We are putting partial factor of safety against our ULS loads also. So this partial factor of safety is very important to take into account all your uncertainties. And that is why you see in your Eurocode 7, in Eurocode 2, we are putting partial factor of safety on material, we are putting partial factor of safety on loads also. Now, here you can see that all our dead load, overburden load, surcharge load, hydrostatic load, seismic load, all are combined. So there are different types of combination that can be that my maximum dead load is applied, my maximum overburden load is applied, my minimum water load is applied, my seismic load is not there. So there can be different loading combinations. So you can make a 10 loading combination, you can make a 12 loading combination. Now, how you define this loading combination? It can be defined as per your different codes. There is a, you can follow the IS code also, because IS codes are not applicable directly for segments, but since the segments are designed as a short column, so you can take into account of the IS codes also, or you can use Eurocode also, you can use ITA guideline also, you can use the Singapore LTA guideline, you can use British codes, whatever it is. The different designer prefers different loading combination, but the loading combination means that all type of loads are getting combined. So whatever the worst combination it is, my design is foolproof against the combination. So it can happen that seismic, hydrostatic, overburden, dead load will not act simultaneously. But still, it is a loading combination, it is a worst combination. Practically, if you see that the seismic, if your tunnel is designed in the 10 years, you do not encounter in seismic, but still you are considered in the seismic, that it is a probability, it can happen anytime. So my loading combination is taking into account of all the probabilities of my consequences or probabilities of failure or probabilities of my safety of the structures. Okay, this I have already discussed. This is the cross passage opening whenever we are constructing a cross passage. So we are breaking the segment. So during the cross passage opening, whatever the stresses, that is additional stresses that is developed in the already installed segments, so you need to check. So your segment should be foolproof against any type of additional stresses that is developed during the distortion or due to additional bending moment. So here you will get additional distortion of the segment, you can get a additional moments in the segment. So additional distortion is being taken by these beep blocks. These beep blocks are basically high capacity dowels. They are taking into additional, they're not allowing the segments to distort or keeping the segments in position. So here you can see this is the dowels or the beep blocks we are generally telling. So cross passage is basically a problem is basically a 3D problem. Our tunnels is a basically 2D problem because it is running along the length. So it has a infinite length. But in a cross passage, it is a connection between a main tunnel and the cross passage is a connection between the main tunnel. So it's a 3D problem. So the junction of the cross passage and the tunnel, high stresses are developed during the opening, even in the service stage. So that is why we are putting an additional frame inside the cross passage. So that is, there are two types of frames we generally design in the cross passage. One is the temporary frame. Another one is the permanent frame. The temporary frame is only to open the cross passage, and once the cross passage is constructed, this temporary frame is removed. There is a permanent frame is put inside the cross passage, that is the inner side of the cross passage or inner side of the opening. There is a permanent frame put, and an additional thickness of the concrete is put at the junction of the tunnel and the cross passage to take into account of the thrust. So basically, these are the additional forces that is developed apart from the normal loads. Okay. So this is all I discussed. This is called the ultimate limit state condition. Ultimate limit state condition means all your forces maximum limit you are designing. So you are designing all your bending moment, all your axial forces, all your shear forces are taken into consideration in your ultimate limit state. And in the ultimate limit state, you are putting a factor of safety of 1.5. If it is a static load condition, if it is a dynamic load condition, we are putting a factor of safety of 1.2. Okay, is it clear, everyone?
Sir.
Okay. Now we come to the serviceability limit state. Serviceability limit state means that you need to check the crack width of the concrete. You need to check the deformation of the concrete. You need to check whether is any additional distortion in the segments, because all your forces that will induce some moments also. So how we do check it? So there are, in the right hand side, you can see there is a table. So there is a deformation, there is a cracking. So deformation means there will be opening in the joint. There might be a joint offset. Cracking means that it can be flexural crack. There will be a shear crack. So this is the SLS part of the segments. So in the SLS part of the segments, what we are doing? So first of all, we need to check the crack width of the segments. Now the crack width of the segments in a metro project, we are using a 0.2 millimeter or 0.25 millimeter. Now there is a standard guideline. This is called the German guidelines. For different conditions, they have specified what is the crack. Now, if the crack is developed, sometimes the client gets panicked that the crack is developed, that my segment has lost its serviceability. That is not the case. Cracks can develop in any segment, but you need to see that what is the, first of all, what are the types of the cracks and what is the width of the crack. So if the crack is not exceeding your allowable crack width over the service period, that means the segment is intact. If the crack width is exceeding the allowable crack width in your service period, that means your segment has been affected. So you need to do some additional strengthening of the segment to make it as a waterproofing structure. So you can see there are different types of conditions of the water ingress. So accordingly, the crack width has been specified. So if it is a dry condition, if it is a moist condition, if it is a wet condition, different crack width has been specified. So you need to first of all see that what is your crack width if the segments has got cracked, and accordingly what is your specified crack width. So in your design segment design, in the SLS condition, you are determining the crack width. So whatever the loading combination and whatever the uh, segment in the reinforcement arrangement you have provided, so you need to check your crack width. So if your crack width, calculated crack width is within your allowable limit, that means your segments are safe against the serviceability limit state. Now we come to the durability. The durability, as I told you earlier, all the segments are currently designed for a 100-year design life. So 100-year design life means in the 100-year design life, if the segment is getting exposed to the chloride attack, if it is getting exposed to the carbonation, if it is getting exposed to the sulfate, acid, alkali, corrosion, any type of, the segment thickness will not get affected. So that is my design life. Design life means that is not the that 100-year it will take the whole load. It means that the serviceability, that it remains healthy, or the concrete does not get corroded, that it does not get affected. There will be a maintenance over the 100 years because the client has to maintain the whole tunnel structure. There will be periodic maintenance, there will be maintenance manual, there will be maintenance frequency, there will be maintenance procedure also. But still within the 100 years, the concrete will not get affected in a serious way, or it will not, the strength will not get degraded. Now, how we define the durability? Define the durability is that, first of all, you have to see that what are the different chemicals that is getting affected. So you can see in the left-hand side, there is a degradation mechanism. So if it is a chloride attack, if it is a carbonate attack, if it is a sulfate attack, how it will get my structure getting affected. So first of all, you have to see that what is the limit of effect of my getting of the structures. Now, second thing is that what is the exposure class? So exposure class, there are different exposure class as per the BS codes, as per the ACI guidelines for different type of the attacks. So if it is a carbonation attacks, if it is a sulfate attack, if it is a chloride attack, if it is a chemical attack, if it is a corrosion attack, so what is the exposure of the attack? Now, according to the exposure of the attack, we specify that what will be my minimum concrete grade. So you can see there are different concrete grades specified for different type of the my exposure class. And accordingly, I have defined the cement content also, because the cement content specifies mostly the concrete compressive strength. And also if there is any other requirement also I specify. And there is also, according to the exposure category, what is the limit of the chemicals. There might be chemical, there might be sulfate, there might be chloride, there might be carbonate in my ground, in my water, but there is a limit, that this is the allowable limit within my serviceability will be ensured. And another thing is that what will be the cover over the reinforcement. So for the different exposure class, and according to the structural class, I specify what is the cover, that is the cover over the reinforcement. So we are specifying 40 cover and 50 cover in our metro projects. But according to the durability criteria, what is the cover as per the standard guidelines? That is the main thing. So in the durability, one is the cover over the reinforcement. Next thing is your strength. What is the strength you are mentioning? What is the cement content you are mentioning? And what is your exposure class? And what is the limits of your chemical exposure? So these are the main things we ensure in our durability. Now, once this exposure class is determined, then you can get this is the standard table for the concrete by exposure class as per the ACI guideline, and accordingly the our mix design is being prepared, and the mix design, once it is finalized by the contractor, then it is run through a standard software called Life 365, which will ensure that what is the minimum design life you can achieve. So if your target design life is 100 years, might be for your standard mixed design, you can get a durability over 250 years, sometimes 300 years. So this is a separate part apart from the design in your segment design, that is called DAR report, durability assessment report. Durability assessment report is very important because once the durability is not properly analyzed, or if the client is not approving your durability report, even your segment design is approved, you cannot cast the segment because the design life needs to be ensured only by your durability. Design life is not related to your loads condition or your seismic or your dead load, whatever the design life is only connected to your durability and serviceability. So nowadays, apart from your design, that is the SLS design, ULS design, whatever you're using, other things are is the fire exposure and the durability, that is the most important in a precast segment design. And this is the standard codes you are using for the segmental linings. So ACI is the American Concrete Institute, AFTS is the French, there is a British code, there is a German code, there is a Japanese code, there is a LTA code, there is an Austrian code. But in the metro projects, mostly we are using the LTA guidelines or we are using the ACI guidelines. And nowadays the ACI guideline, the American Concrete Institute guideline, they have developed a very step-by-step process of the segment design along with very detailed example, along with very detailed case studies. Okay, so this is the basis of the precast segment design. Okay, anyone have any type of query, any type of question? Everything clear to everyone?
Yes, sir.
Yes, sir. Got a good overview. And I guess
Uh,
need to go through the presentation again.
Yes,
And
yes, please go through the presentation again because this is a very new subject and this is a very complicated subject. I understand because this is part of the, sometimes it is a part of structure. But if you need example, I will provide. If you need any code, any reference, I will provide you because it's a very detailed and complicated thing. The segment design is not straightforward as a tunnel lining design, whatever the conventional lining design we are doing, because here there are lots of things getting connected because it starts from your production, from your handling, then your final service design, and in the final service design it is also connected with your dimension of the segment, then comes the fire design, then comes the serviceability, you design the durability to the, and nowadays the design process is more advanced because we are taking into, if you are taking into account of the 100-year design life, then you have to really prove the 100-year design life. It's not that you tell that this amount of cover I have provided, this is my chemical exposure. So they, every client now wants a very detailed demonstration of these things. But
okay, sir. So after reviewing that PPT,
please.
maybe if any doubts, would post on WhatsApp, I guess.
Pardon?
Is that okay, sir? So if I got any doubts, I would post it on WhatsApp.
Sure,
Is that
sure,
okay,
sure, sure. Any type of doubts, any type of queries, any type of further, any type of reference, please send me a message. I will definitely reply you. Okay?
sir? Thank you, sir.
Okay. Okay.
Sir,
Thank you
one
very much.
question.
Yes, sir. Yes.
Sir, doing the modeling, we generally use the double spring model. We
Double
model
spring.
two ring at a time, right?
Can you please elaborate your question?
Sir, normally right you showed we prefer the non-crucified joint. We staggered the your longitudinal joint. So to the take the advantage of the that staggered segment configuration, your Japanese guideline or your BS guideline is preferring that if you doing one single bring spring model, and if you are providing two bring spring model and connection between and establish the connection between the bolts by springs or your radial springs, then that is more economical. More your the bending moment and shear force will be less.
Okay.
So can you have any?
Actually, I have never done what I did in my projects. I first of all I determined my forces by Muirwood method or Dudekman method. Then I compared these forces only with FEM models. I have never done beam spring model for the segments. Beam spring model for the segments only we have done in the grouting load cases or fire load cases. But for the main reinforcement design, we mostly relied on this Muirwood or the FEM methods. But the FEM method, what I did, as I told you, I considered an interface between the ground and the segment. And that is the, in that part, I have considered the grouting load.
APM model is every time is giving less bending moment and shear force compared to the Muirwood.
Compared to Meerut, it gives less, but this was objected by the client in one of my project. He told that FEM model cannot give very less, because if you compare the FEM model and the Meerut model, it should not be that you will tell that my Meerut is 50% higher than FEM model. It should not be that, because both are based on the same elastic theory. Muirwood is also an elastic theory. In FEM model, you are also doing the elastic theory. So why it should be different? So at the end, we brought that the both results were within 5 to 10%. It should not be that if I am doing a beam spring model, I can get a very high forces, because in the beam spring model, the loads are directly distributed on my tunnel lining. In a FEM model, it is because of the mesh arrangement and because of the interaction, my loading will not fully come. But the question is that in the FEM model, I am not allowing any relaxation. If it is a ground relaxation, then the less load will come on the lining. As I am not allowing any relaxation, 100% load is going in my FEM model. Similarly, 100% load is going also in my Muirwood method. So why the two model will differ results? And if you want, I can send you my project case study, but the FEM results and the Muirwood results were quite similar. Because in an NATM tunnel, it can happen. Because in NATM tunnel, we are allowing relaxation. So practically 30%, 40% load is going to the lining, because 60% is gone due to the relaxation. But in a TBM segment, we are not allowing relaxation, because in a metro project, it is strictly written that no relaxation is allowed. So 100% loading is going into the FEM model, 100% loading is going into the Muirwood method. The Muirwood method is a theoretical method. You are making a hand calculation, you are making an Excel spreadsheet, you are determining the forces, the bending moment and the axial forces, the shear forces on a particular loading condition. But in FEM, we can do a multiple loading condition. We can get the segment forces all at every point of the segment. That is not possible in Muirwood, because Muirwood gives only one set of force. But the forces, maximum force will not differ too much. It will not that 35%, 50%, it will vary. It will vary between 5 to 10%. And that is one of the projects we demonstrated that both forces were similar. Because if the Muirwood method is giving a different force to compare to FEM method, then I cannot validate my design. Then there is no point to comparison to two methods.
Okay, thank you.
Because this is one of the misconception of the people, that structural model will give definite high forces. It will give high forces because in a structural model, you are not considering the ground effect. You are considering the stiffness by only the springs. But in a FEM model, you are considering the Poisson's ratio, stiffness, you are considering the layering of the ground, you are considering the cohesion, friction. So that is why it is a realistic. So it is considering the load sharing concept also. But if it is a segment model, there is no account of load relaxation, there is no account of load reduction. So 100% loading is going in both cases. So it should not differ too much. If it is a NATM lining, I can argue. Okay, in NATM lining, we are considering relaxation in FEM model, but we are not considering relaxation in a structural or a beam spring model. So beam spring model will definitely give a higher amount of forces. But in a precast segment, this should not be that case. Is it clear?
Yes, sir. It is clear.
Okay. Anyone have any other question? Okay, let us close here. Please post your questions, post your feedback, post your queries, or if you have any other requirement, please, I will definitely respond and I will forward the recording also. Okay.
Okay, sir.
Okay. Thank you very much.
Okay, thank you, sir.
Thank you.
you.